Hi everybody and welcome. Today we're going to be talking about the Pythagorean Theorem. So today, after watching this video, our goal is to be able to identify real-world examples and also calculate missing lengths using the Pythagorean Theorem. So to get us started off, where does this come into play? So if we have a 90-degree or a right triangle here, we're going to be able to calculate missing side lengths using the Pythagorean Theorem. So if you've ever wondered, you're like leaning your ladder up against the wall, and you have a couple of lengths that you know or you can measure. So maybe you can measure, this distance on the ground, but your tape measure kind of just is flip-flopping all over the place and can't really reach up to where the ladder is touching there. Well, if you know the length of your ladder and you know the distance it is from the wall, you'll be able to calculate that height there. So a useful example too, if you need to do this on scratch paper, like I think for example, my ladder is like 22 feet tall. And if I need to calculate, all right, if I need to get to the top of my house, get on my roof, is a 22-foot ladder long enough, or do I need a larger ladder? So again, another example there where we can use this practical knowledge to see if what we have works. So if we're thinking about ladders, I don't know off the top of my head exactly what it is, but there is a good ratio that you want to make sure you have it from the house. Otherwise, it's, you're going straight up and it might fall over on you, and you'll be one of those like funny movie clips where the person's like flying through the air on the ladder. Don't want that to happen. So again, always good to use that. And this is, again, a useful skill, calculating any unknowns with triangles, but again, more specifically, some right triangles. So just a couple things to remember, but again, a second useful life skill that we're seeing here. So jumping in here, I'm going to go to our definition next. So first, let's define the Pythagorean theorem. And again, pulling up this definition, we'll be in good shape. So we define this as a relationship between the sides of a right triangle. So specifically and only a right triangle. So we can use it in something like this, but we cannot use it for an unknown in a triangle like that. And what is the Pythagorean theorem? Well, a squared plus b squared equals c squared. So again, using those things there, we'll be able to calculate some unknowns for a triangle. And honestly, a pretty useful real-life formula here. So let's first go through an example here. So we'll start off with question number 2. And a couple of important things to define here as well. C squared is always the hypotenuse, or the longest side. So in this figure, this is our hypotenuse, or our longest side, our diagonal. In this figure, it would be 19. So a good first step whenever you're solving is always make sure we understand where c squared is. We can interchange a and b. We have to make sure we identify c correctly first. So an example like number 2 with a squared plus b squared equals c squared. Well, okay, we can have 5 as a and b is 13. So 5 squared plus 13 squared equals c squared. So calculating that, we want to go one step at a time. So we'll have 25 plus, I believe that is 169, equals c squared. If we put both of these together, we'll get an answer of 194 equals c squared. And that's not our answer, that's c squared. We have to take the root of both of those to get to c. So again, we don't want 194, we don't want c squared, we want just c. So to do that, actually a messy decimal here, we'll get like 13.92, or 13.9. So we can leave it as that, and that is our missing side length. So again, a little bit of calculation needed here. We're taking those square roots, but we're in good shape. And a final thing to check for reasonableness, we said that c is our longest side. Well, of 5, 13, and 13.9, 13.9 is the longest side, so that works for reasonableness there. Second question that we can set up here together. So again, we know that c is 19. A or b, doesn't matter which one, is 17, but we don't know that final missing side length. So again, we'll have 17 squared plus b squared equals 19 squared. And let's see what this is when we calculate it out. So 17 squared gets us 289. Again, still don't know b squared. And then 19 squared will get us to 361. Still doing algebra steps. Just we have some exponents now, but that's okay. So b squared 361 minus 289 gets us to 72. And then the square root of 72. Again, not a clean answer here. Once more, get 8.485, or we'll call it 8.5. And again, checking for reasonableness, C is still our longest side. It looks like B should be less than A, so 8.5 does look like an okay answer for us there. So again, these questions, we are identifying A, B, and C, taking a look at which one we don't know, and then using that constant proportion formula, A squared plus B squared equals C squared, to solve for the unknown. So let's try one more application here. If we don't solve this one, we'll just get it set up. Some word problems. So two joggers run 8 miles north, so they go up like this, and then they go exactly 5 miles west. So if they take that sharp turn going west, they should look something like this. And then the shortest distance to get to their starting point, well, we have to just basically connect the dots. We're going to see we have a right triangle. So that's going to be our C side, our longest side. So now it's our job to set up our A squared plus B squared equals C squared and solve for the missing length, the C length, to get back. So quick recap for these, especially with word problems, always good to draw a diagram to know what we're solving. If we do those things and follow those steps, we will be in good shape. So as always, any questions, definitely reach out. Go through some of these practice problems.